teachers, welcome to the first video on the CPA approach. In this video, we will explore what CPA is and how it is applied in mathematics. In the next two videos, we will dive deeper into the different stages of CPA and how they can be effectively implemented in your classrooms. For today's sessions, we will need some writing materials such as papers and pens. You may pause the video to get your materials. Okay, now it's time for a warm-up activity. I will be showing 3 words, one at a time, for about 1 to 2 seconds. Your task is to remember the words and write them down on a piece of paper. So, are you ready? First word, second word, third word. Okay, I will give you some time to write down the answers on the piece of paper. So, these are the answers for the 3 words. Did you get everything correct? Why do you think you did not get everything correct, especially the last word? This leads us to the CPA approach. So CPA stands for Concrete, Pictorial, and Abstract. So CPA. So CPA approach is an effective way of teaching mathematics that develops deep and sustainable understanding of mathematical concepts in learners. CPA was developed based on American psychologist Jerome Bruner's theory of representation. It was then popularized by Singapore's nationwide success in student achievement for mathematics. Okay, so let's say that you show the word toothbrush to a 3-year-old kid. Is the kid going to understand what the toothbrush is or what it is even? No. So that is why we have to introduce this toothbrush, how to spell it, how to write it step by step. So first is the concrete stage where we show the kid the toothbrush itself. We let the kid hold the toothbrush, use the toothbrush, and is able to understand how a toothbrush even looks like. And then we move on to the pictorial stage where we show the kid books with the spelling of toothbrush. So for example, in this picture here, you can see that the tiger is holding a toothbrush and there's also the spelling of toothbrush. In this way, they are able to connect how a toothbrush looks like, what a toothbrush is, to the spelling of the toothbrush. And that is the pictorial stage. So once they are familiar with the concrete and pictorial stage, and lastly we move on to the abstract stage where you just show them the word toothbrush and they are able to recognize that, this is what I use to clean my teeth. This is what I need to use every morning and every night. Mathematics can be difficult for children and even adults because it is really abstract. The CPA approach builds on learners' prior knowledge and experience by using objects to introduce abstract concepts. So in this example of CPA approach in math, let's say we want to teach the students how to do 10 minus 4. So firstly, in the concrete stage, we give them some cubes, some manipulatives for them to figure out how to solve the problems. So these physical objects are used by the students moving around and playing around, and they learn by doing. And then we move on to the pictorial stage, which is learning by seeing. So visual representation of concrete objects are used to model problems. So in this case, we are using a number line. So from 10, we are moving 4 steps back, and then we get the answer of 6. So similar to the concrete stage, just that we are using physical objects. 10 cubes, we take away 4 cubes, we get 6. Likewise, in the pictorial stage, we are representing these cubes here. So 10 minus 4 is equals to 6. And lastly, we go to the abstract phase, which is using symbols. So this is when the teacher introduces abstract concepts by using only numbers and mathematical symbols such as plus, minus, multiply, and divide. After demonstrating a solid understanding of concepts in the concrete and pictorial phases, learners will rely only on these numbers and symbols to solve the problems. So abstract is the symbolic stage where children use symbols to model problems. So by this point of time, students are able to understand that 10 minus 4 is equals to 6 without using cubes or even the number line. So why use CPA approach? The 3 main benefits of CPA approach is that comprehensive learning. We really understand the concepts. We have deep understanding of the concepts learned. Not only that, but it also provides a smooth transition. So instead of straight away teaching the students 10 minus 4 is equals to 6, where students are just memorizing, there's a smooth transition where we allow the students to play with cubes, followed by showing a pictorial representation of the cubes, and then finally they're understanding what is actually minus, how do we get 10 minus 4. And lastly, the third benefit is that it enhances problem solving skills. So why does it enhance problem solving skills? In math, we don't always have simple and straightforward basic questions such as 10 minus 4 is equals to 6 or 8 plus 8 is equals to 16. No, instead we have a lot of problem solving questions where, for example, the question says Billy had 10 sweets in total. He gave away 4 of them. How many sweets does he have in the end? So when students are just exposed straight away to 10 minus 4 is equal to 6, they are not going to be able to apply the concepts learned into the problem, which is why CPA approach works the best for mathematics. Okay, so let's see CPA in action. How do you teach students how to divide fractions by a whole number? So let's say 1 over 4 divided by 3. How would you do it? So maybe you might just write this on the board. So 1 over 4 divided by 3 is 1 over 4. You swap the 3, you put the 3 below in the denominator. So it's 1 over 4 multiplied by 1/3. And you multiply the denominator, which gives you 1/12. So let's say you just write this on the board. Are students actually going to understand why 1 over 4 divided by 3 gives you 1 over 12? Okay, so let's say even your stronger students understand this concept. What if you give them this kind of questions where it's more application-based question? Will your weaker students be able to solve this question? So this is why we are going to be using the CPA approach. So now back to the same questions on teaching how to divide fractions by a whole number. Okay, so what I want you to do now is take a piece of paper, fold it into half, and you'll get this. And I want you to fold the other half of the paper into another half such that you get a quarter. So this is how you may want to teach your students as well. You may pause the video to fold the papers. once you have gotten this quarter, I want you to fold the quarter piece of paper into another 3 different parts. So it needs to be divided into 3 equal sections. So this is when you show, okay, this is the 1/4 and we divide it into 3, which is why we are folding it into another 3 sections. So this illustrates 1/4 divided by 3. And I want you to shade one section of the rectangle just like this. Okay, so once you have shaded one section of the rectangle, you have to unfold the paper and then it reveals 12 smaller sections with one section which is shaded. So this is how you can explain to students that each shaded section represents 1/12. Why? Because there are 12 different sections here and only one of them is shaded. So if you notice, we began by using concrete materials to represent 1/4 divided by 3. By folding a quarter, the quarter piece of paper, into 3 equal sections, students are visually able to see how the original fraction, 1/4, is divided into smaller parts. Shading one part of the folded fraction and then unfolding the paper demonstrated that each of the 12 resulting sections represents 1/12. This hands-on activity made the abstract division process more tangible and easier to grasp. And once they've understood why 1/4 divided by 3 gives you 1/12, they have a conceptual understanding of this fraction divided by a whole number, they can now then proceed to solve application-based questions. So Abraham Lincoln has said that if you give him 6 hours to chop down a tree, he will spend the first 4 hours sharpening the axe. So this is what we are doing in the CPA approach. We are spending 2/3 of the time getting students to actually understand the concepts. So not just memorizing it, but they really know what it means. And by doing so, they are able to apply concepts to unfamiliar questions. And this also helps the weaker students understand even better. And by doing all of this, they are able to achieve procedural fluency, where they know what are the different steps to take, when to perform what kind of calculations, and to solve word problems efficiently. Okay, so we have now reached the end of the first video of CPA. The next video, I'll be explaining more about the concrete phase. So you may click the link below in the description box to go to the next video. Thank you.